February 19th, 1945. D-Day, Iwo Jima. 9:02 in the morning. The first Marine hits the beach at Red Beach 1 and immediately understands that the intelligence reports were wrong. Not wrong about the defenses existing, wrong about where they were. The 74 consecutive days of naval bombardment, 6,800 tons of ordnance, 22,000 large-caliber naval shells had stripped the island's surface of every visible structure, every above-ground position, every obstacle that could be identified from a ship or an aircraft. What it had not touched was what mattered. The defenses were not on the surface, they were in it. Private First Class Howard McLaughlin of the 4th Marine Division, who survived the battle and dictated an account to a Marine Corps historian in 1947, described the first 30 minutes in terms that appear in his recorded statement with a specificity that cannot be invented. The black volcanic sand that swallowed every foothold, the absence of any visible enemy, and then the fire that came from everywhere simultaneously, from positions that could not be located because they had no above-ground signature, from apertures that opened for a single burst and then sealed before the round reached them. He said, "You couldn't find them. You could die from them, but you couldn't find them." By the end of the first day, the 5th Amphibious Corps had landed approximately 30,000 Marines on Iwo Jima and had taken 2,400 casualties. 36 square kilometers of volcanic rock, 8 square miles, the most fortified position in the Pacific War. The island that General Tadamichi Kuribayashi had spent 11 months converting from a volcanic outcrop into something that had no precedent in the history of modern warfare, and that conventional weapons, artillery, naval gunfire, aerial bombardment, infantry assault, had almost no capacity to reduce. What reduced it, in the end, was fire, liquid fire, delivered from a modified M4A3 Sherman tank, poured from 150 yards through every aperture and across every surface that a concrete bunker had been unable to seal, reaching into the places that no shell and no infantry assault could reach, finding the men who were certain that their underground fortress had made them unreachable. 8 tanks, 8 modified Shermans. Of all the assets committed to the bloodiest battle in Marine Corps history, 60,000 men, 450 ships, 7,000 tons of ordnance, 3 weeks of preliminary bombardment, the weapon that the Marine Corps later identified as the most decisive single contribution to the operation was 8 tanks built by men from the Naval Construction Force in a vacant field at Schofield Barracks, Hawaii, using techniques that no military procurement manual had authorized and that no general had thought to request until the battles that preceded Iwo Jima made the need impossible to deny. This is the forensic account of those 8 tanks, of the engineer who built them, of the underground fortress that made them necessary, and of the specific mathematics of what it costs when a defensive system is finally made to answer for its own design. The underground fortress that Kuribayashi built on Iwo Jima was the product of a calculation that required him to accept his own defeat as a premise. General Tadamichi Kuribayashi had studied at Harvard. He had served as a military attaché in Washington. He had watched American industry produce equipment at rates that Japanese industry could not match. He had read the after-action reports from Saipan, from Guam, from the Philippines, and had extracted from them a single conclusion that broke with every tradition of Japanese military doctrine. The standard defensive tactics, the forward beach defense, the massed banzai counterattack, the honorable death in open combat, were producing catastrophic Japanese casualties while delaying the American advance by days, not weeks. They were not working. Not because the men who executed them lacked courage, because the doctrine was wrong for the enemy they were fighting. He was appointed to command Iwo Jima's defense in June 1944. He arrived on the island with 11 months before the projected American landing date and a workforce of 21,000 men. He gave them one instruction that contradicted everything his own training had told him was true. They would fight from underground. The engineering project that followed was, by any objective measure, one of the most significant military construction efforts in Pacific War history. Japanese engineers, working under Kuribayashi's direction, carved 11 miles of interconnected tunnels into the volcanic rock in the 11 months before the American landing, with plans to extend the network to 17 miles before the invasion came. The completed sections reached 7 stories below the surface at their deepest points. The volcanic rock of Iwo Jima, basalt and compressed ash, laid down over centuries of geological activity, was ideal for this purpose, hard enough to maintain tunnel integrity without extensive reinforcement, soft enough to be worked by hand tools where machinery could not reach. The numbers that define the fortress are these: 5,000 individual caves and underground chambers, ranging from single-man fighting positions to structures large enough to shelter 400 men. 1,500 fortified surface positions, concrete bunkers with walls 4 feet thick, reinforced with steel salvaged from abandoned pre-war construction projects on the island, positioned with mathematical precision to provide interlocking fields of fire that covered every beach, every approach, every flat ground between the coast and the island's center. The largest underground structure, beneath Hill 382, contained a chamber 50 meters long and 20 meters wide, a single underground room capable of holding an entire infantry battalion. The ventilation system was a feat of engineering improvisation that still commands the attention of military historians who study it. Shafts disguised as natural rock formations, oriented to take advantage of prevailing wind patterns, providing breathable air to chambers 7 stories underground without any mechanical assistance. Underground hospitals with operating theaters equipped for 400 wounded. Communications centers buried 75 feet below ground, connected by miles of telephone wire to every significant position on the island's surface. Storage chambers with enough rice, water, and ammunition for a 2-month siege, because Kuribayashi had planned for a siege, not a defense. His men would not break and run. They would not counterattack and die in the open. They would stay underground, absorbing everything the Americans could deliver, and continue killing until they were killed individually, position by position, in a process that Kuribayashi calculated would cost the Americans enough dead that the invasion of the Japanese home islands might be reconsidered. He was wrong about the strategic outcome. The calculations changed in August 1945, for reasons that had nothing to do with infantry or fortifications. But he was not wrong about the tactical problem he had created. His underground fortress was, by any military analysis, essentially impervious to the weapons the Americans brought to the first day of the battle. The surface bombardment had destroyed fewer than 200 of the 1,500 fortified positions. Most of the Japanese garrison had sheltered underground during the 3 weeks of preliminary bombardment without significant casualties. The craters left behind by naval shells, 16-inch rounds from battleships, which the men who fired them had expected to scour every defensive position from the island's surface, had actually improved the Japanese defensive situation by providing additional cover for fighters who emerged to engage the marine assault and then withdrew through the tunnel network before the inevitable counter-bombardment arrived. Kuribayashi had built something that the standard American military toolkit of 1945 could not directly defeat. What he had not anticipated was Colonel George F. Unmacht and the 25 men from the 117th Naval Construction Battalion who were at Schofield Barracks when the 5th Amphibious Corps placed its order for flame tanks. Colonel George F. Unmacht commanded the Chemical Warfare Service in the Central Pacific area, a posting that, in the peacetime Army, would have been a modest administrative assignment managing stocks of defensive chemical agents and conducting the training exercises that the Chemical Warfare Service was required by doctrine to perform, regardless of whether anyone expected them to be relevant. The wartime Army had discovered in the Pacific Campaign that the Chemical Warfare Service had a relevance that peacetime doctrine had not anticipated. Not its defensive gas mission, which had not been needed, but its offensive capability with incendiary weapons. Flamethrowers, backpack-mounted devices that projected a stream of burning fuel at close range, had been used in the Pacific since Guadalcanal. They worked. They worked with a specific effectiveness against fortified cave and bunker positions that conventional weapons could not match, because fire did what a bullet or a shell could not. It entered through apertures too small for a man, filled enclosed spaces with burning material, and denied the underground shelter that had made Japanese defensive positions so difficult to reduce. A man behind 4 feet of reinforced concrete was protected from artillery. He was not protected from burning fuel pumped through the ventilation slot. The problem was the backpack flamethrower itself. The standard M2A1-7 portable flamethrower that American infantry carried weighed 68 pounds when fully fueled. Its effective range was 20 to 30 yards, close enough to a fortified bunker that the man carrying it was well within the lethal field of fire of every weapon defending that bunker. The casualty rate among portable flamethrower operators in the Pacific was, by the time of the Iwo Jima planning, a number that senior officers knew and did not advertise. In some island operations, portable flamethrower operators had suffered casualty rates approaching 90%. The weapon worked. The men who carried it to within 20 yards of a Japanese fortification frequently did not survive the approach. The Canadian Ronson flamethrower system, acquired by the Marines in 1944, mounted on M3 Stuart light tanks and designated Satan, had extended the range and reduced the personal risk to the operator. But the M3 light tank's 37mm armor was insufficient protection against the Japanese 47mm anti-tank gun that was standard equipment in Iwo Jima's defensive positions. Satan tanks had been destroyed by defensive fire before they could complete their missions, and the Ronson system's fuel capacity allowed only 30 to 40 seconds of continuous fire, barely enough time in many cases to begin reaching into the deeper cave positions that Kuribayashi's engineers had constructed. What was needed was a weapon that combined the range and protection of a medium tank with a flamethrower system capable of sustained fire at distances that kept the vehicle outside the effective range of the 47mm anti-tank gun. The specification, worked out by Marine Corps observers after Saipan and Guam, was unambiguous. Minimum effective range of 150 yards, fuel capacity for at least 60 seconds of continuous fire, mounted on an M4 Sherman hull whose armor could deflect the 47mm round at combat ranges. No such weapon existed. No procurement process had authorized its development. No military-industrial contractor had a design for it. The path to that specification had been 3 years of field improvisation conducted simultaneously by the Army and the Marine Corps in different theaters, each learning the same lesson independently. The first mechanized flamethrower in American Pacific service had been conceived by an officer in the 754th Tank Battalion on the island of New Caledonia in 1942, a field modification to an M3 Stuart light tank that mounted a portable flamethrower inside the hull and projected the stream through an aperture in the glossus plate. The modification worked in the specific sense that the flame reached the target. It failed in every other sense. The range was limited to 20 yards, the fuel capacity was the same 30 seconds of a backpack system, and the M3 Stuart's armor was sufficient to stop rifle fire, but not the weapons that Japanese defensive positions carried. Modified Stuarts were destroyed on New Georgia in 1943 before the lesson was recorded formally enough to influence procurement. The Ronson flamethrower system represented the next generation. Designed for the Churchill infantry tank and acquired by American forces when the Churchill itself was unavailable for Pacific operations, The Ronson used a pressurized fuel system that extended range to 60 to 80 yards and fuel capacity to 30 to 40 seconds. The Marines acquired 30 units for installation in M3 Stuart hulls, the resulting vehicles designated Satan tanks, and employed them at Saipan in June and July 1944. The Satan tanks worked better. They did not work well enough. The 47mm anti-tank gun could defeat the Stuart's armor at combat ranges, which meant the Satan had to approach within the gun's effective engagement zone to use its own weapon. 3 of the 30 Satan tanks were destroyed by anti-tank fire at Saipan before reaching positions where their flamethrowers could be employed. The surviving crews developed oblique approach techniques that improved survival rates, but could not solve the fundamental problem. The weapon's effective range and the gun's effective range overlapped in a band where the tank was simultaneously trying to use its weapon and trying to avoid being destroyed. The after-action reports from Saipan and Tinian, compiled in August 1944, contain the requirement in a single sentence. The flamethrower must engage from outside the defensive weapon's effective range, or the weapon is not viable for sustained employment against prepared positions. The 5th Amphibious Corps placed its order with Wehrmacht's Chemical Warfare Service in September 1944, 5 months before the projected landing date on Iwo Jima. Wehrmacht had 8 M4A3 Sherman tanks in a vacant field. He had, in addition, something more valuable than either: access to the 117th Naval Construction Battalion. The Seabees, the United States Naval Construction Force, their name derived from the initials Seabee for Construction Battalion, were the most practically skilled engineering force in the American military in the Pacific. They had built airstrips across the Central Pacific in time frames that conventional military engineering would have deemed impossible. They had constructed harbor facilities on islands whose beaches were still contested. They had laid pipeline across jungle terrain that no survey map had accurately described, run telecommunications cable through conditions that destroyed standard equipment, fabricated replacement parts for machinery whose manufacturers were 3,000 miles away on the American mainland. They operated under the organizational philosophy that the Naval Construction Force had built into its culture from its formation in 1942. If something needs to exist and doesn't, you build it, using whatever materials are available in whatever time is available to whatever standard the mission requires. This philosophy was not a slogan, it was a selection criterion. The Seabees recruited men with pre-existing trade skills: carpenters, electricians, pipe fitters, machinists, welders, mechanics, who understood the practical relationship between a problem and a material solution. The average age of a Seabee in 1944 was 37 years, compared to 26 for the average Marine. Men who had spent decades developing specific technical competencies before the war drafted them into a uniform and gave them a problem that matched those competencies exactly. Machinist Mate First Class A. Riker had been a Marine engineer on the West Coast before the war. He had spent 15 years understanding how fuel moved through systems under pressure, how pipe diameter and pump rate and viscosity interacted at the engineering level that produced reliable delivery rather than theoretical performance. When Wehrmacht gave him the problem of moving 290 gallons of thickened napalm from the hull storage to the flame projector nozzle at the pressure and volume rate that a 150-yard range specification required, Riker approached it as a plumbing and fluid dynamics problem. He knew what those problems looked like. He had solved variants of them before. Electrician's Mate Second Class Joseph Clay had been an industrial electrician. His specific pre-war expertise was ignition systems for industrial burners, the devices that lit furnaces and boilers and the other large-scale combustion equipment that American industry operated. An ignition system for a flamethrower was a specific version of a problem he had solved dozens of times, in systems that were larger and more complex than anything a tank turret could contain. The scaling was downward, which was easier than scaling up. The combat environment was more hostile than an industrial plant, which required the system to be more robust. But robustness in electrical systems was an engineering discipline with established solutions that Clay had learned before the war. This was the specific advantage that the Seabees brought to Unmacht's program. Not general military capability, but specific pre-existing expertise, matched precisely to the technical requirements of the problem. Unmacht could have obtained military personnel with technical training. He could not have obtained, through military channels, men who had already spent careers solving the exact variant of problems that building the POA-CWS-H1 required. Unmacht requisitioned 25 men from the 117th. They assembled at Schofield Barracks in September 1944 with the 8 M4A3 Sherman hulls, the Navy Mark I flamethrower systems that had been selected as the baseline for the installation, and a set of performance specifications that had never been met by any previous mechanized flamethrower system in any military's inventory. The engineering challenge was significant in ways that extended beyond the obvious. A standard M4A3 Sherman tank was not designed to carry 290 gallons of thickened napalm fuel within its hull, plumbed to a modified main gun barrel from which a compressed nitrogen propellant system would project a sustained stream of burning material to a range 3 times that of any previous mechanized flamethrower. The Sherman's crew compartment contained, in the POA-CWS-H1 configuration, a driver, an assistant driver who doubled as the flame system operator, and the tank commander, a crew of 3 rather than the standard 5, because the space requirements of the fuel and propellant systems displaced the positions that a gunner and bow gunner would have occupied in a standard tank. The fuel tanks were positioned against the hull sides, replacing the ammunition racks that a gun-equipped Sherman would carry. The propellant nitrogen was stored in high-pressure cylinders that occupied the former ammunition storage areas. The main gun mount was modified to accept the flame projector nozzle in place of the 75mm tube, a modification that required fabricating new mounting hardware from materials available at Schofield Barracks, to specifications that no standard military drawing covered. Riker's fuel delivery system went through 7 versions in the first 6 weeks of development. The initial versions failed at the pressure boundary between the storage tanks and the delivery pipe, a failure mode that produced fuel leakage within the hull at the precise location where, in combat, a spark from battle damage would have catastrophic consequences. Versions 3 through 5 addressed the pressure boundary but introduced a flow rate inconsistency that produced an intermittent stream rather than the sustained continuous delivery that the range specification required. Version 6 achieved continuous flow, but at a viscosity that the Mark I nozzle had not been designed to handle, producing atomization at the nozzle rather than the coherent stream that sustained range required. Version 7 modified the nozzle geometry to match the fuel viscosity and achieved the 150-yard range in the first successful test. Clay's ignition system went through 4 versions. The first version used a standard industrial spark igniter that had a reliable performance record in industrial applications and failed consistently in the electromagnetic interference environment produced by the tank's electrical systems, which generated the same frequency range that the igniter's spark gap operated on, creating false triggering and misfires at a rate that made field use impossible. The second version shielded the igniter against the specific frequency ranges produced by the tank's systems, an approach that worked in static testing and failed under the mechanical vibration of vehicle movement, where the shielding developed microfractures that degraded its effectiveness within hours of operation. The third version replaced the spark gap with a piezoelectric igniter that was inherently immune to electromagnetic interference and mechanically robust under vibration. But the piezoelectric system required a specific triggering force that the flame system's manual controls could not reliably deliver. Version 4 modified the trigger mechanism to produce the consistent triggering force the piezoelectric element required, and achieved reliable ignition in the first full system test. The completed system was first tested in static configuration, the tank stationary, the flame projector aimed at a fixed target, in late November 1944. The test was conducted at night, which was Unmach's choice. He wanted the observers to understand what the weapon looked like in conditions closest to combat: darkness, flame visible for significant distances, the sound and heat and light of 290 gallons of napalm burning at that standoff distance. He later wrote that the decision was practical. He wanted to ensure that the Marines who would be following the tanks understood what they would be following. But the effect he described in his Naval Proceedings account was closer to shock than to practical assessment. The night demonstration at Schofield Barracks, conducted approximately 3 weeks before the Iwo Jima landing date, was attended by Marine Corps officers, including representatives of the 5th Amphibious Corps staff. The official observer reports are measured documents. Range confirmed at 150 yards. Fuel duration at 63 seconds of continuous fire. System reliability through 5 consecutive test firings without malfunction. The handwritten additions in the margins of several reports are different. They are the language of men who had spent years in the Pacific watching infantry die at close range in front of fortified positions, and had just seen a weapon that could engage those positions from a distance no man had to cross on foot. Unmach submitted a request for additional units. The request could not be fulfilled before the February 19th landing date. 8 tanks had been built. 8 tanks would go to Iwo Jima. They landed on D-Day and went into action on D+2, February 21st, when the situation on the beaches had stabilized enough to bring the Shermans forward through the volcanic sand that had slowed every vehicle since the first hour of the landing. The volcanic sand of Iwo Jima was itself a tactical problem that no preliminary analysis had fully anticipated. The island's surface, black basalt ash, compacted by geological pressure but loose enough to swallow a vehicle's track under load, provided no firm footing. Standard Sherman tanks moving across Omaha Beach in June 1944 had operated on packed sand and gravel. The Shermans at Iwo Jima moved through a surface that the track grousers could not grip, that collapsed under the vehicle's weight, and that required the tank's engine to work continuously at high throttle to maintain movement in any direction. The fuel consumption was 2 to 3 times what level ground operations would have required. The mechanical stress on the final drive was correspondingly higher. The 8 POA-CWS-H1 tanks had been built for the combat they would face, not for the ground they would cross to reach it. They crossed it anyway. The first confirmed engagement of a POA-CWS-H1 at Iwo Jima is documented in the after-action report of the 5th Marine Tank Battalion, which recorded it on the morning of February 21st at a cluster of bunker positions near the East Boat Basin, where 3 Japanese reinforced concrete positions had held against infantry assault and conventional tank support for approximately 18 hours. The Marine Infantry Battalion holding the line in front of those positions had taken casualties attempting to reduce them with organic weapons, rifle fire, grenades, 60mm mortars, the 68-pound portable flamethrower carried by 2 men to within 20 yards of a position that was already killing everyone who came within 40 yards of its apertures. The Mark I, the Marines' field designation for the flame tank, was brought forward and positioned at 120 yards from the nearest bunker, outside the effective range of the 47mm anti-tank gun in the position. The flame projector fired a 3-second burst at the nearest aperture. The after-action report is written in the compressed language of military documentation that makes its content more striking for the understatement. The position was rendered inactive after a single, sustained application. No subsequent fire was received from the position. The language means that everyone inside it died. The second position was engaged at the same range, 2 3-second bursts. The third position, which had been receiving flame from the first engagement, the napalm mixture's physical properties allowed it to flow across surfaces and into adjacent openings, required only a single burst before it ceased to function. 3 positions, 18 hours of infantry stalemate, 7 minutes of flame. The 5th Marine Tank Battalion observer who wrote the engagement report added a note outside the standard reporting format, a note that appears in the archive document as a handwritten addition to the typed form, which suggests it was written immediately after the engagement rather than in a subsequent review. Recommend immediate additional employment. Effect exceeded all expectations. As the battle progressed and the Marine assault moved north toward the island's plateau and the heavily fortified central terrain that Kuribayashi had made his primary defensive line, the pattern of that first engagement repeated itself with a consistency that permitted systematic analysis. The flame tank's presence in a sector changed the tactical mathematics of assault in ways that extended beyond the positions directly engaged. The Japanese defensive system on Iwo Jima had been designed around the assumption, a correct assumption based on every previous island battle in the Pacific, that American infantry advancing against fortified positions would be compelled to approach within the effective range of those positions before delivering the weapons capable of reducing them. The 47mm anti-tank gun would stop the armor. The infantry would then face the bunkers with portable flamethrowers, satchel charges, and direct fire from weapons that the bunker's concrete walls could largely deflect. Japanese defenders, operating from covered positions with interlocking fire, would exact a specific and predictable toll on each assault. The POA-CWS-H1 changed the distance term in this calculation. The 47mm gun could not reach the tank at 150 yards with the penetration force needed to defeat the Sherman's hull armor at that oblique angle. The infantry following the tank remained beyond the effective range of the Japanese small arms fire directed from positions that were occupied with the more immediate problem of a burning stream arriving through their apertures. The formula that Kuribayashi's engineers had worked into every position on the island, the specific relationship between weapon range, armor penetration, and infantry assault distance, stopped being valid as soon as the Mark I appeared. Marine Corps observers in the later stages of the battle documented what they called the psychological effect in terms that now appear in the standard histories of the Pacific Campaign. Japanese defenders in sectors where flame tanks were operating began withdrawing to deeper tunnel positions before the tanks reached them, not abandoning their weapons, moving deeper, attempting to preserve their capability for defense of the inner positions, rather than dying in the outer ones that the flame had already made untenable. This withdrawal pattern, which Marine intelligence began identifying around the battle's 10th day, reduced Japanese defensive effectiveness in the sectors where it occurred, because a man 2 levels deeper in the tunnel system was less able to engage the surface than a man in the frontline position, but also reduced Marine casualties in those sectors, because the infantry following the tanks was encountering fire from positions that had been partially evacuated rather than fully manned. The Japanese military archives, open to researchers in the 1980s, provided a perspective on this withdrawal pattern that the Marine after-action reports could only infer from observed behavior. Japanese unit diaries and command post logs from the Iwo Jima garrison, cross-referenced by military historians in the decade after the archives became accessible, documented the specific progression of the flame tank's psychological effect through the battle's middle and later stages. The earliest references to the flame tanks in Japanese records are tactical. A weapon of unknown type has appeared in the eastern sector. Effective range greater than our anti-tank capability. 3 positions destroyed in the morning of D+2. The language is the language of an operational update, clinical and specific. The references from D+7 through D+14 are different. They describe not tactical facts, but psychological states. The specific experience of being in a position that the surface-level doctrine of the Japanese defensive system had classified as protected, and watching that classification become meaningless. One unit diary, from a garrison element holding positions in the Central Plateau area, recorded on approximately the 10th day of the battle. The flame tanks have made our above-ground positions untenable. We are withdrawing to the secondary tunnel level. The men understand that withdrawal is not defeat. They are withdrawing because they have seen what staying produces. That last sentence is the most precise description any Japanese source gave of what the POA-CWS-H1 accomplished beyond its direct physical effects. The men had seen what staying in a surface position produced when a flame tank appeared at the engagement distance. They had seen it produce the cessation of the position. They had incorporated that observation into their behavior without requiring an order. The psychological deterrence was operating independently of command authority, which meant it was operating faster than any command structure could respond to it. Marine intelligence officers who analyzed the withdrawal pattern after the battle noted that it had a specific operational consequence that no amount of pre-battle planning had predicted. As the battle progressed and Japanese defenders withdrew to deeper tunnel positions in sectors where flame tanks were present, the flame tanks' direct effectiveness declined, because the deeper positions were inaccessible to the tank's flame projector, while their indirect effectiveness increased, because the defenders occupying those deeper positions were doing less damage to the Marine infantry than the defenders who had formerly occupied the surface positions. The flame tanks were winning engagements they were not physically participating in, through the accumulated behavioral change produced by the engagements they had participated in. The Marine After-Action compilation, produced at V Amphibious Corps level after the battle, included a statistical table that expressed the direct effect in quantified terms. In sectors where POA-CWS-H1 tanks were available and employed, Marine assault unit casualty rates ran approximately 60 to 70% lower than in comparable sectors where flame tank support was unavailable. The indirect effect, the withdrawal pattern, the behavioral change, was present in the data but could not be separated from the direct effect with the analytical tools available in 1945. One battalion commander, Lieutenant Colonel Don J. Robertson of the 1st Battalion, 27th Marines, submitted an observation quoted in the compilation. The Mark I accomplished in minutes what would have required hours or days and cost dozens of lives using any available alternative. His arithmetic was not imprecise. It was the arithmetic of a man who had watched both approaches and counted the results. The portable flamethrower operators, who had been the primary tool for cave and bunker reduction in previous Pacific operations, were still in the battle. Their casualty rate, 92% by the end of the campaign, was not reduced by the flame tanks. The situations requiring portable flamethrowers remained: positions inaccessible to armor, apertures too small for the tank's projector at standoff range. What the flame tanks had done was reduce the number of those situations. Every position the Mark I could engage from 150 yards was a position no portable flamethrower operator had to approach from 20. The 92% casualty rate was appalling. Without the tanks that removed the positions the tank could reach, it would have been higher. In the tunnel network beneath Hill 362, which fell to Marine assault on March 9th, the 19th day of a battle that American planners had projected would last 5 days, General Kuribayashi moved his command post progressively deeper as the flame tanks systematically reduced the surface positions above him. His communications with Imperial General Headquarters, conducted by radio through the deepening interference of battle, became increasingly terse. His final messages to Tokyo, transmitted in the last days of March 1945, have been preserved in the Japanese military archives and were made available to researchers in the 1980s. The final operational message, transmitted on March 21, 1945, 4 days before Kuribayashi's death, contained a passage that has been quoted in every significant history of the Iwo Jima campaign since those archives were opened. He wrote, "The Americans have not defeated us with superior numbers or superior firepower. They have defeated us with superior imagination. They transformed our greatest strength, our underground fortifications, into death traps. Future wars will belong to nations that can imagine new forms of warfare, not those who perfect old ones." Stop at that sentence. Kuribayashi was a professional military officer making a technical assessment in the final days of his life, with the precision of a man who had studied military science at Harvard and who had no reason at this point to deceive himself or anyone else about what had happened. He was not describing courage or luck or the fortunes of war. He was describing an engineering solution to a specifically engineered problem, an improvised weapon system built in 5 months by men whose names appear in no headline, used by 8 tank crews against a fortress that had been a year in the building, and which had been, for the first 18 days of the battle, effectively impregnable. Imagination. That was his word. Not technology in the abstract. Not American industrial capacity, which was a known fact he had lived with since 1944. Imagination. The specific act of looking at an existing problem and conceiving a non-standard solution, then building it in 5 months because there was no other time available. The verdict is in the numbers. The Battle of Iwo Jima lasted 36 days, 31 more than American planners had projected. The Marine Corps suffered 6,821 killed and 19,217 wounded. The Japanese garrison of 21,000 was almost entirely destroyed. 18,375 confirmed killed, 216 prisoners. Admiral Nimitz gave the Marine Corps the commendation that became its most quoted. "Among the men who fought on Iwo Jima, uncommon valor was a common virtue." He was correct. He was not describing the most decisive element of the battle. The Marine Corps after-action analysis identified the POA-CWS-H1 as the best single weapon of the operation. 8 tanks. Over 36 days, directly engaging more than 1,000 fortified positions. 60 to 70% reduction in the SALT casualties against prepared positions in every sector where they operated. Colonel Anmacht published his account in Naval Proceedings in April 1948, a professional journal, 3 years after the battle, a technical audience. Riker and Clay appear in the program records and in Anmacht's acknowledgments. Their names appear in no popular account of Iwo Jima. Kuribayashi received posthumous promotion to full general by imperial decree. His final message has been quoted in military schools for decades. He was describing the Seabees. He did not know their names. The fortress had an answer for everything. 11 miles of tunnels. 5,000 positions. Concrete that deflected naval shells. A 47-millimeter gun that stopped every tank the Americans had previously brought to the Pacific. It did not have an answer for what 25 men built in 5 months in a vacant field in Hawaii. That is the forensic record. That is what won.